Basically, the focus of the discussion today is really this transition that's beginning to take place from the rotary screen printing environment. I'm using the word rotary to sort of encompass all of the screen printing technologies, although we know that in the conventional printing world or the traditional printing world, screen printing actually covers a range of systems, not all of them rotary based, but rotary being the primary production solution. And we're in the midst of this transition to more digital solutions. The technologies are becoming more production oriented, and we're beginning to see that there's some tremendous adoption taking place. Companies are interested in taking advantage of these new machines that have higher productivity, and we're beginning to see some significant growth in the digital print market in terms of the amount of fabrics printed. So what does the technology look like today? Essentially, it's high-speed solutions. These solutions also offer fairly high-resolution printing. The printhead technologies are very robust, and in order to support the kind of speeds that we're talking about here, there's been a fair amount of engineering of the systems themselves. Pretty robust fabric transportation systems, and when I move through some of the photographs, you'll get a sense of what I'm talking about here if you've not had an opportunity to see some of these systems at trade shows or in other presentations, or even at your own facilities. One of the interesting things about the printhead technologies that are out there in the marketplace, there's been a lot of work in these systems to be able to run a variety of ink chemistries through them. On the more higher production type printhead technologies, in at least one case, there's a pretty rigorous testing program, certification program that has to ensure that an ink chemistry is compatible for continuous jetting or for optimal jetting through the heads. Many of these systems have the ability to put down multiple ink drop sizes, and that's really important in terms of the image quality that you're able to achieve and the ability to get a lot of chemistry on the fabric to sort of recreate the vibrancy that we're used to in the screen printing environment. There's also, as these machines get faster, there's also been a lot of work on the software side because you got to be able to feed the beast. So there's got to be an ability to rapidly process data and keep the machine running so that there's not pausing. If you think about back in the day with your inkjet printer, when you sent a print to a desktop printer, you used to see some pausing when you were printing graphic intensive images, and that's not really that different from these technologies. Of course, computer processing power has increased, but there has been a fair amount of kind of engineering, software engineering design work behind the scenes to make sure that that works well and that companies can change sort of seamlessly from one design to the next. Of course, color and the ability to manage color is super important, and to be able to create workflows, automated workflows that really can help to sort of speed up how files move through a digital print system. In addition, as you get sort of higher speed technologies, you have to be able to feed them as well in terms of ink chemistries. So there's a lot of emphasis on bulk ink supplies and what we would describe as bulk ink tanks, where you're, instead of having that sort of classic cartridge that you change in and out of the machine, there's big tanks that feed the equipment. And in addition to that, something called inline degassing, because air in the inkjet lines is one of the main reasons why these machines sort of fall out. And so you have to be able to pull that air, keep that air out of the system in order for it to run effectively. And then of course, we want to be able to print on all kinds of fabrics, which, as most of you know, you have to match your fabric type, your fiber type, to your ink chemistry. And so there's multiple ink chemistries available, and most of the machines that are production oriented have the ability to handle both wovens and knit kinds of constructions. And there's also some specialized equipment available for very specific sorts of printing processes or printing substrates. And then in addition to that, particularly of relevance to companies that have not traditionally been involved in textile printing, there's also been the introduction of auxiliary equipment that really supports the fabric preparation and the finishing processes. And most importantly, where dye-based printing is concerned. So sublimation printing / dispersed dye printing, as well as reactive and acid dye printing. And now that we're beginning to see pigments come into the market to a greater degree, there's also some technology and some, particularly on the chemistry side of things, that really revolves around preparation of fabrics to improve the color output for pigments and potentially some of the color fastness characteristics. So essentially what we're beginning to see in a nutshell are new classes of equipment are entering the market. Where we used to see kind of the bulk of technologies offering print rates in the range of less than 20 meters per hour, now we're beginning to see an increasing number of solutions where the print rate is somewhere in the range of 30 meters per hour, and even in one case, a solution that enables printing of greater than 30 meters per minute. And I say greater than 30 meters per minute. This particular company quotes kind of the top speed on this technology, and I'll show it in a few minutes here, at somewhere in the range of 70 meters per minute. But as you know, production equipment, it does not always run at the optimal speed, so there's a bit of a range there. Okay, so Mark Sawczek from Expand Systems, he sort of likes to categorize these printing technologies into classes. And you can see here he's broken it up into 4 classes. And essentially class 1 and class 2 have been around for a while. It's really class 3 and class 4 where we're beginning to make some inroads. And as we make some inroads in those kinds of speeds, we see houses that are more traditional textile printers beginning to bring these more robust solutions on to serve their customers. Okay, so cost. Everybody's always interested in cost when it comes to digital printing. These are not my numbers, so I'm not really able to defend them per se. But essentially what we're beginning to see with these higher speed solutions is that we're beginning to become more comparable with rotary screen production. And if anybody wants a copy of this presentation or wants to go to the source to ask more questions about this, I'm happy to point you in that direction. But the whole goal is really to sort of get into the under $1 per linear yard range for digital. And we really haven't been in that space in the past. I touched on, kind of in my introduction, a little bit about software and some of the challenges and development that's happened in the software area. I talked about already the optimization of drop sizes, and as I mentioned, the ability to sort of control what size of drop you're putting down on a piece of cloth has to do with image quality, the kind of tonal effects you can create. Also the level of color saturation that you can achieve. But in the digital world, ink is gold. That's, as you know, materials and manufacturing and soft goods manufacturing tends to be sort of the higher element of the cost scenario. And so really the ability to put down just enough ink, but not too much, is important. So having a lot of control in that area is very helpful. And some of the software solutions really enable you to fine-tune how you mix colors. So in the digital world, it's primarily a process color world, meaning that you work with cyan, magenta, yellow, and black. And in many cases, and I'll use sublimation printing as the exception to that, where it's typically a 4-color process approach. In reactive dye printing and in pigment printing and acid dye printing, oftentimes there are what we call gamut expanding colors, which really enable us to achieve a much wider range of printable colors. And in particular, in the black area, one of the challenges has been to really be able to produce a very saturated, vibrant black. And if you can't produce a good black, you can't produce good navies and good forest green type colors. So some of the software solutions out there allow you to do things like, for example, create a rich black, where in the inkjet environment, you're just not using black droplets of ink to create black. You're taking black and you're adding, it's probably an old dyer's trick, you're adding other colors to it in order to create a richer hue. And so of course that means you're putting down more ink, and there's sort of some science behind how you want to introduce those other colors to build that saturation through the gray tones from a light gray value all the way to the deepest, darkest, richest black you can create. Some software solutions also provide the ability to manage soft spot colors, which is super important in where companies are kind of working within a more traditional textile printing environment. They may have CAD systems that are used for color separation, or they may be trying to work with a seasonal color palette where they're matching specific hues. So at the digital printer, it's very important to be able to manage those spot colors. That said, a lot of companies use a combination of management of spot colors and also the ability to print more photographic or artwork that we would never actually go through a color separation process. So depending on the nature of the business, some of these features are more important than others, I guess is what I'm trying to say. The ability to replicate the screen printed effect initially was important for a lot of customers because it had to do with how digital printing was being used as a tool for sampling. As we begin to see digital printing be a larger tool within the production environment, the digital sample can drive digital production. So the ability to actually replicate fall-ons and kind of recreate the mesh effect, the effect that the mesh creates on a printed substrate may become less important, but there are solutions that speak to that. A lot of the technology vendors that come out of the graphics industry or the graphics side of the world, companies like Caldera and ErgoSoft, they specifically have tools for managing workflows so that you can really automate how you would sort of pre-press an image as it goes to the printer. And then of course there's lots of interest in being able to track and predict how much ink is going down on the fabric, which is really important to cost analysis activities. And this is just a list of kind of the key vendors that exist in the software marketplace. I would say one of the most important things that has happened in terms of driving this production printing capability forward is advancement in printhead technologies. And for many, many years, Epson was kind of the leader. They dominated the marketplace in the textile printing solutions. But now we're beginning to see companies really branch out from that, and there's a couple of reasons. Epson is like the best in the world at being able to create really fine photographic detail. You can't beat the Epson technology for that. But that's not always the most important thing for a lot of the textile users. And basically, there has been a need to make use of printhead technologies that are really more robust, where you can really give them a workout. And in some cases, these print heads are less disposable than what, I mean, the Epson heads are not really disposable any longer. The price of them has gone up over the years. But certainly if you compare them to printhead technologies from companies like Kyocera, where you're talking about $8,000 for a single printhead, it's really, there's quite a difference. But the printheads have been designed for more industrial purposes. And in some cases, they're larger, and in many cases, you're able to bank those printhead together to create what we call arrays, which enable the ability to cover, you think of the printhead of the digital print process as being a traversing process in general, where the printheads move back and forth across the width of the substrate. So if you can clump those printheads together and cover a wider swath of fabric, you can print faster. And in one example, a company has created a continuous bar of printheads that makes for a stationary array. So this is kind of the top of the line, highest speed solution out there in the marketplace. It's called the Aereo, some people refer to it as Aereo. But basically this is what we call a fixed array technology. It was developed by MS Printing Solutions, an Italian company that's sort of just outside the Como region. And they have a number of solutions available, but this is the highest speed of the family of technologies that they've developed. It does make use of that Kyocera printing technology, and I have a couple video clips. You may have seen these before in other presentations, but bear with me. This is the machine that has the capability of reaching up to, let's see, up to 70 linear meters a minute. What we're looking at here are basically the stations where the arrays are. So I think on this machine there are up to 8 arrays, and we just passed each of them. It almost looks like a bus or a train. And each of those arrays delivers a single color. And then you can see how it's integrated with, I think that was the dryer on that end. Here's another clip that shows it printing. So you can see how as it moves under the next array, it puts down another color. Makes use of a sticky blanket. And there it's moving into a conveyor dryer. Okay. This is the printing panel. So it's printing at about 31 meters per minute at the moment. And that's what that looks like in terms of speed. Now they're speeding the machine up. So one of the neat things, as I understand it, about this, oops, sorry, I didn't mean to play that again, about this technology, I guess I gotta move off the screen. One of the neat things about this technology is that as the fabric feeds onto the belt, sometimes you get bubbles or sort of uneven application onto the belt, and apparently the print heads sort of jump over those bubbles, so that, because if you get collision between the fabric and the head, you could cause nozzle failure. That's just kind of a little side note. So this is just showing how you can switch quickly from one design to another. So unlike the screen process where there's a lot of setup, this is just sort of illustrating how flexible the technology is. This, I think the first version of this machine, or the first installation of this machine was at Aereo in Italy. And as I understand it, the company is also creating a paper printing version of this machine for the sublimation process as well. But this is just a look at kind of the bulk ink supply and the more industrial type dryers that are being assembled on the front of these faster machines, because of course, unlike kind of the wide format paper versions, they printed slow enough that you didn't really have to dry the fabric before winding, but you do when you begin to increase the speeds. And of course, material handling has become a super important feature. That's something we're learning a lot about at Spinflower. Big rolls. Okay. So I mentioned earlier that on the ink side of the world, there are a number of options. All of the options, all of kind of the key options that are used in conventional printing, reactive and acid dyes, and also the development of what's described as typically a universal set that provides a little bit of substrate flexibility in the acid reactive world. And also dispersed dyes. And in the dispersed dye printing area, this has been one of the big drivers for technology development, is the adoption of digital processes or digital printing in the sublimation market. And the dispersed dye area is kind of an interesting area because as this adoption has taken place and companies have begun to use it for more than just sign and banner, there's been increasing development of sort of specialized ink chemistries to optimize specific properties. So for example, for the flag industry or for outdoor applications, companies are interested in higher light fastness properties, and so there are cases where vendors have developed solutions that are specifically targeted toward that. They selected the colorants. The colorants set a little differently. In this market, the bulk of what is done is considered sublimation, where companies are printing on paper first and using heat to transfer the color from the paper to the fabric. Those sublimation inks are also being applied, in some cases, directly to the substrate. So companies are then pre-treating their fabric to control the spread of the color, but they're essentially using sublimation chemistry or lower energy chemistry in order to print in the dispersed area. Of course, there are also higher energy dispersed dye inks available, and particularly for companies who are interested in, for example, automotive type applications. That's a different process and a different set of chemistries, but as you all know, kind of in the same family. And again, these inks specifically being formulated for the more industrial type print heads. And some of the specific development activities here are really around the ability to improve color yield. There's been a fair amount of work on the chemistry itself, but also on the papers that are being used within the transfer environment to help increase the movement from the paper into the fabric. And there's been an awful lot of adoption of sublimation printing in Europe in particular within the fashion marketplace. John Provost, who some of you may know, has estimated this to be something in the range of 50% of the digital market worldwide is associated with dispersed dye, sublimation in particular. And as a result of that, as I mentioned, some companies are beginning to, technology vendors are beginning to create more production-oriented systems that are specifically engineered for printing on paper, which feeds, of course, a little bit differently than fabric. Reggiani at a show, at least within the last year, one of the European digital technology shows, showcased a paper printing machine. And MS also has a couple of different versions of their paper printing machine, and now in development, I guess, on the high-speed Aereo printer. This is just a clip of kind of one of the other solutions MS offers, the JP6. This is an older video clip, but excuse me, it shows you what paper printing looks like. Very similar to fabric printing. One of the nice things about the sublimation process is that for companies who are just starting out in digital printing, the cost of entry is fairly low because there's very sort of wide format paper, low cost roll-to-roll systems available for printing on paper, and relatively modestly priced transfer, calendar type transfer printing units that can be paired with that for low to medium type production applications. But as the needs increase, the other nice thing about sublimation printing, sorry, these videos are a little noisy, but the other nice thing about sublimation printing is that these machines oftentimes run at higher speeds than some of the other dye-based printing processes, and that's because typically in sublimation they only run 4 colors. So if you had an 8 8-head arrangement, you could double up the number of heads and effectively double the speed of the machine. That's a pretty long video, so I think you get the idea. Okay, so of course MS is not the only technology provider out there in the industry. This technology has been developed by Durst, and Durst is a longtime player in the inkjet world. Their technology, the Kappa 180, has been purchased by a company in the UK called Standfast and Barracks. Is anybody familiar with Standfast and Barracks? They are a traditional screen print provider, and they have a business where they print with with pretty much I think all chemistry types, including pigments. And they, as I understand it, now have 2 Durst Kappa 180s, and they're running dye-based chemistries in those machines that seem to be having a fair bit of success in their production environment. I mentioned already Aereo of Italy as being kind of the early adopter of what I'll sort of call the class 4 super high-speed printing systems, and Aereo has kind of crafted a whole environmental story around their adoption of the technology, and has really pointed to the ability to minimize their consumption of water and reduce their waste streams as a result of their digital adoption. I think more and more of their production is moving over to digital. I'm not that familiar with this particular company, but it's a home furnishings company in Spain that makes use of some equipment that Stork offers. And I believe they serve both the fashion and the home furnishings area, but primarily home furnishings as I understand it. Brazil has been a region where there's been tremendous adoption of digital printing. And in particular, a lot of technologies by MS are being used in that region, although I'm sure not exclusively. And of course, digital printing in China. And I'm not as familiar with what's happening in China, but it's my understanding that there's kind of a collection of technologies being used. There has been some development of technology, in particular by Chinese vendors. There are a number of ink chemistry providers coming out of China, particularly in reference to sublimation and also in reference to pigment printing. But you can see in this particular facility, they make use of sort of a lower cost, many machine type model. And in some cases that offers a tremendous amount of flexibility. This image is not from Shran Digital in South Carolina, but this is a solution that they have adopted for sublimation printing. And they also have a higher speed, what's called a JPK model, fabric printing model of the MS technology, which is the tier just before you get to the Aereo solution. Pigment printing is an area that's a little bit near and dear to my own heart, because that's primarily what we do at Spoonflower. And this is a more challenging chemistry, or has been more challenging chemistry to develop for the inkjet environment, but it offers tremendously simple processing as compared to some of the dye-based systems that require both fabric pretreatment and wet post-processing. So there are a lot of advantages in the context of our business, which is an entirely internet-based print-on-demand scenario. The ability to quickly turn orders is tremendously important, and in fact we offer a rush service that enables that. And that's just a quick look at what our facility has looked like. Now we have a couple of larger scale printers that we're in testing mode on. But we take advantage of that model, at least currently, of many lower cost printers. This is one of the newer solutions in the marketplace that's specifically designed for printing with pigments. This is the Kornit Allegro technology. And again, this is one of the solutions that we're currently testing at Spoonflower. And the interesting thing about this system is it has an integrated pretreatment solution. They call it FOF, or fixation on flight, but essentially the pretreatment is delivered by one of the heads in the system, and it goes down only where there is color. And so in the past, when some companies have developed pretreatment solutions for pigment printing, they've applied it to patted it on, or sprayed it on, used other processes, and it's contributed to kind of a boardy feeling on the fabric, and so that's one of the potential advantages here. But the pretreatment does create for quite a vibrant color scenario. So that has been a really interesting project for us to test. One of the main applications, or the main drivers for development of pigment-based chemistry, has been the digital garment printing market. And there are lots of different solutions out there in this area. Quite a number of providers that offer low cost, what we describe as kind of technology suited for mom and pop shop operations. Some people operating out of their garage. And in many cases, these technologies are modified desktop Epson printers. And essentially they're 4-color or 4-color plus white. And the 4-color plus white is really designed to enable printing on colored t-shirts, so black t-shirts. So they put down like a white block up first and then apply the color over top. The print rates in this environment are pretty modest, but we are beginning to see some larger format multi-platinum printers. In fact, multi-platinum printers have been out there for a while now. What's newer is really beginning to see the introduction of more industrial print heads. So by Aereo Jet Brother and Epson, within the last year, has introduced a digital garment printer into the market. And this is thought that this is going to be a very disruptive technology, because basically companies have been buying Epson printers and kind of re-engineering them for the garment printing market. And Epson has taken note of that and said, we're not going to let that happen. We're going to get out there ourselves. So it'll be interesting to see what happens to all these other providers. I think there's some frazzled nerves out there on that front. We'll see. On the high production front, Kornit has really been the company that has dominated this market, making use of more industrial print head solutions. This last year, kind of in line with the Allegro roll-to-roll printer that they've introduced, they've also introduced a 6-color garment printer that makes use of red and green in addition to the CMYK. So the color gamut's beginning to broaden. One of the tricky things about these garment printers is that the users have to be able to load and unload when the machine gets faster really quickly, and that has been a challenge in terms of processing in the case of this particular machine, which is designed to print very high speed. That's been one of the primary criticisms, is how could anybody possibly run the machine? So lots of attention there. And there's also some flatbed garment printing technologies available, specifically a solution from Shimaseki that's kind of designed to go with their whole garment printing technology. And the one place that I know that this is installed, in addition to a Japanese location, is at the Auckland University of Technology in their Textile Design Lab, and they use it with lots of projects. This is an example of some of their student work where they're integrating their printing process with whole garment knitting processes from Shimaseki. And that machine prints with both reactive acid and pigments specifically. So one last little equipment thing before we wrap it up here. Aereo has combined with their garment printing company, MHM, to develop this Aereo Jet Machine. And what's interesting about this is essentially it combines both the digital and screen print processes. The screen printing carousel is used to apply white and the discharge paste. And in the digital printing world, it's the application of the white that is really the time-consuming thing. So this is kind of an interesting concept that could potentially speed that up. And then the digital technology is sort of stationed at one point in the carousel in order to apply the colored image over top. So just to kind of throw out a little quote here, Epson estimates that the garment printing market will be worth over 200 million euro by 2014. So we're already in 2014. This was a quote taken out of the digital textile issue toward the end of last year. But basically what they're saying is this is one of the reasons why they decided to get into this market, is because there's tremendous opportunity here. And I think we will continue to see the growth of the use of industrial print heads and more work on the pigment chemistry, which has been, I would say, kind of one of the challenges in the pigment world. Any questions?